Good morning! Rise and shine! It's me, Teacher Ann. Are you ready to learn? Alright, so we have 2 lessons for today. Please open your book to page number 7. Let's study the tensile strength and hardness. The third property of material is the tensile strength. Can you spell the word tensile strength? Very good. Job well done. So what is tensile strength? Material tells how much force can be applied without breaking the materials. The first type of tensile strength is the low tensile strength. The low tensile strength will break when a small force is applied to them. It's like this picture, a wood. Wood can be easily to break. What do you see on the picture? Yes, a boy is holding a chopstick and he can break it easily because a wooden chopstick has a low tensile strength. The second type of a tensile strength is the high tensile strength. Will break only when a very large force is applied to them. So as you can see, the man trying to bend the metal, which he exerts too much force for him to bend the metal. What about this picture? The boy is holding an iron rod. So what do you see? Yes, iron rod has a high tensile strength. It's not easy to break or bend. Watch this video.
Let me describe for you another cellulose version, which again we use for its structural properties. Cotton wool. Right, if I take out a nice chunk of that, we're all used to cotton wool, jolly good for cradling things, and it's all made of fibers. That's all extremely familiar to us, cellulose fibers. And if we twist this, I'm a rather inefficient at this. If you do that efficiently by machine, then that is the thread that you get. You get a cotton thread. And that's a useful thing for sewing up things and holding things and so on. Very important structure. And then we can think, okay, but well, that's not much good, is it? It's not very strong. That's a rotten piece of thread. But what I want to try and impress on you is the fact that it's actually a bit stronger than it looks. That's a rotten little demonstration. So let's have a competition. We're going to have a molecular competition. Very simple. Thank you very much. Here's the arena for this competition. Now, can I have a couple of volunteers? Thank you very much. I need a team, you see. Thank you. Please come down. What's your name?
Simon.
Simon. Hello, Simon. And your name?
Victoria.
Victoria. Okay, jolly good. Now, I want one of you to be Cotton, and so you can be there. Okay, and you can come this side, Victoria. Okay, now let me just explain what this extremely sophisticated demonstration is. Okay, what we've got here is a steel wire. Steel. It's made of steel. And on this side, we've got a wire which is made of cotton. Right, now, which do you think is stronger, cotton or steel? How do we test this? This is a Royal Institution tensimeter. It's a fancy name for it. Right, okay. Now, what we're going to do is successively load these wires with weights, which are hiding behind here. So will you put on a weight, please? Thank you very much. That's a 0.5 kilogram weight. Okay, so that's 500 gram weight on each one. Very gentle, so we don't perturb anything. And notice that the tensimeter is reading 500 grams. Right, okay, and both of them are holding. Let's have another one. Very good. Very good. We're now up to 1 kilogram. Tensimeter's reading that on each side. Exciting, isn't it? Right, okay, let's have another one. And, oh, it's gone. But his is holding. That's the steel one. So the steel one has gone first. All right? I tell you what we're going to do, Victoria. We're going to borrow one of your weights and give it to Simon. Would you like to try that on yours and just see if it'll take one extra? And it's still holding. Right. Thank you very much indeed for coming to help us with that. That's fine. So there must be something special happening in this cotton thread to make it so strong. And if we're going to find the reason for that, we must go, thank you very much, we're finished with that, we must go to the molecular level. If we want to understand phenomena, we must go to the molecular level. Chemistry. Right. Now I remember that I said that this thread was made up of glucose units all stuck together. Here is the glucose molecule. Now, let me just tell you about the structure of this molecule. First of all, this red ball is an oxygen atom. And the pale blue ball is a hydrogen atom. And if you look at this molecule, you'll see that that grouping, this hydrogen-oxygen grouping, is represented several times in this molecule. And it is actually the association of these hydroxyl groups, HO groups, together in the thread, which make that thread strong. These are sticky groups, and we're going to come back to molecular stickiness. Now let me just take you from the individual unit to a model of cellulose. Here we are. A string of glucose molecules, and the sticky groups that we've just seen represented by these white dots. Okay? So now let's go up from this model, this molecular model of cellulose, to a piece of thread. Okay? And if we stretch that piece of thread down the length of that model, then what we are doing is representing the thread at the molecular level. And it is the stickiness between these chains of the hydrogen-oxygen grouping that we've just seen, which gives cellulose its strength. In this case, its tensile strength. It's a molecular association phenomenon.
It's a very interesting experiment, right? I hope you gained knowledge from this video. Let's talk about the fourth property of material, the hardness. So what is hardness? Can you spell hardness? Correct. So what is hardness? A material is its ability to withstand scratches. We can compare the hardness of two materials by doing a simple test as shown in the diagrams. We have here the iron block and the toothpick. So we use the toothpick to scratch the iron block. What do you think? Can you see any mark on the iron block? Okay. No, because the toothpick does not leave scratch marks on the iron block. Next, wooden block and the iron nail. So if you use the iron nail to scratch the wooden block, what do you observe on the wooden block? Right, you can see the scratch on the wooden block because the iron nail leaves scratch marks on the wooden block. Please open your book to page number 12. Which material is hardened? So here are the steps. Step 1, collect the following materials from the teacher's bench. We have 1 piece of marble or limestone, 1 wooden block, 1 piece of rubber, 1 piece of glass block, 1 piece of acrylic, 1 piece of granite, and 1 piece of iron nail. Step 2. Use each item to scratch another item. Observe the position where the scratching path. Place a tick in the box if a scratch was observed. Now, let's answer the items. So item 1, iron nail, 2, marble, 3, wood, 4, rubber, 5, glass, 6, acrylic, and 7, granite. So let's use the iron nail to scratch the iron nail. So they are the same. What do you think will happen? Is there any scratch? No. What about the iron nail and marble? Can you see a mark or a scratch? Right? Iron nail to wood. Yes. So let's use the iron nail to scratch the rubber. Do you think you can see any scratch or marks on the rubber? Yes. Iron nail to glass. Right. Iron nail into acrylic. Correct. So let's use the iron nail to scratch the granite. Do you think there is a mark on the granite? Correct. Next item, marble. Can we scratch the iron nail using the marble? No. Marble to marble? No. What about marble to wood? Yes. So let's use the marble to scratch the rubber. Do you think there is a scratch? Alright. Marble to glass. What do you think? Alright. Marble scratching the acrylic. Do you think there's a scratch? Yes, you're so right. Marble to granite. Correct. So let's use the wood to scratch the iron nail. Can you see any mark or scratch? No. What about wood to marble? No. Wood to wood? No. Wood to rubber? No, correct. What about wood to glass? No, we cannot use the wood to scratch the glass. What about the wood to scratch the acrylic? Right. There is a mark on the acrylic. Next, the rubber. Can we scratch the iron nail? No. What about the marble? No. Rubber to wood? No. Rubber to rubber? No. What about rubber to glass? No. Rubber to acrylic? No. Rubber to granite? Still no, because rubber is so soft. Let's proceed to glass. Can we scratch the iron nail using the glass? No. Can we scratch the glass? Or can we scratch the marble using the glass? Correct. Let's use the glass to scratch the wood. Alright. Glass to rubber. Yes. What about glass to glass? No. Using glass to scratch the acrylic? What do you think? Yes. Glass to granite. Can you see any scratch? Right. Next, acrylic. We use acrylic to scratch the iron nail. What do you think? Cannot. Acrylic into marble? Not. Acrylic to wood? Not. Acrylic to rubber? Yes. What about acrylic? Scratching the glass? Not. Acrylic to acrylic? Of course not. So acrylic to granite? No. Okay. The last one. We use granite to scratch the iron nail. What do you think? No. Granite to marble? Yes. Granite to wood? Yes. Granite into rubber? Yes. Granite to glass. Yes. Granite, acrylic. Yes. How about granite to granite? No. Third step, rank the items from the softest to hardest. Softest, rubber. Next to rubber is the acrylic. Wood, marble, granite, glass, and iron nail. So iron nail is the hardest. Please open your book to page number 12 and answer the questions. I hope you learned something new today. See you next time. Goodbye.